In section 9.2, we talked for a while about absolute value. Do you remember absolute value? You're like, absolutely. Get it, Mr. Leonard? I'm so funny. I go, yeah, you're hilarious. Yeah, we're going to talk about absolute value for a little bit because we're going to combine, here's where this chapter's going. We did inequalities, we're doing absolute value. Next we're going to combine absolute value with inequalities and look what that does. So this is going to be kind of interesting. Absolute value equations. Can you tell me, what does absolute value calculate, or what's it determine?
The distance from zero.
Say that louder for
The
me.
distance from zero.
That's exactly right. Did you guys hear back there? Good. So if absolute value calculates the distance from zero, how much is the absolute value of 9?
9.
What that's saying is that 9 is just 9 units away from 0. It's basically how much would you have to count to get there. What's the absolute value of negative 12? Good. It's basically like I'm standing in the middle of this room with a tape measure and saying this. I'll go this way. About how far am I from that wall? It looks like about 10 feet. So if I took my tape measure out, it's going to give me 10 feet, right? But if I turn around and measure to this wall, that's about 12 feet. Is it going to give me negative 12 feet that way? Tape measure is still going to give me 12 feet, right? Even though it's a completely different direction, distance doesn't matter. It's just saying you're a certain distance away from something. That's what absolute value does. It says absolute value of 9 is 9 because positive 9 is 9 units away. Absolute value of negative 12 is 12 because negative 12 is 12 steps away from 0. You with me? Even though that was a negative, we're talking about the distance from 0. So basically, if you want to think about it this way, absolute value takes a positive number and keeps it positive, takes a negative number and makes it positive. What about this one? 8 or negative 8? What do you think?
Negative 8.
Why doesn't that change to positive 8? I don't get it.
That is outside.
All right, so it's only that negative's only applied to the absolute value if it's inside of that. So this is basically saying, what's the absolute value of 8? And then take the opposite, or take the negative of that. So this happens to be negative 8 for sure. So the difference between here and here, if the negative is outside of the absolute value, it doesn't really get applied to that. Now this is all fine and good. This is stuff you've had before. This is all the way back in like pre-algebra days. What we haven't really talked a whole lot about is what happens if you have an equation. So for instance, what if the absolute value of x equaled a number? Could you tell me how much x is? 5. Yeah, 5 would work, right? Because if I took the absolute value of 5, that would give me 5, wouldn't it? Okay. 5. 5 would work. Well, wait a second. So a couple other people said a couple other things. What'd you say?
Negative.
Well, wait a second. Why negative 5?
Because absolute value is going to turn positive.
Oh, so if I plug in positive 5, the absolute value of 5 is 5, true? If I plug in negative 5, what's the absolute value of negative 5?
5.
Hey, it works. So with absolute value, we get, how many solutions do you think all the time? Yeah. Because here's what it does. Absolute value doesn't care whether something's positive or negative. It's going to make it positive no matter what. So if I'm looking for 5, I could substitute in here both 5 and negative 5, and they would both work in this equation. True? Well, that's kind of interesting. That really doesn't happen that much. How about this one? Absolute value of y equals 12. Does that still have 2 solutions?
Yep.
What are they?
You got a positive.
Good, all right. Because if I plug both of those things in there, they are both going to give me positive 12. How about this one? How many solutions does that one have?
1.
Yeah, there's no negative 0, right? So this is the only time where you actually get just one solution. So if it's equal to 0, then yeah, that's the only thing that's going to work. Negative 0 doesn't really make sense to write.
Not possible.
absolute value of x equals -3, what are you going to get out of that one?
You can't do it.
Well, why can't you do
You
it?
can't get a negative number out of an absolute value.
So if I plug in anything here, if I plug in 3, what's the absolute value of 3?
3.
Okay, if I plug in -3, what's the absolute value of -3?
3.
Can I get -3 from an absolute value?
Only the negatives outside that.
Okay, so this, that would be possible, wouldn't it? But negative, sure, because I can plug in 3 or -3 and both change it to negative. But if I do that with no negative sign, is that possible?
No.
That would be a problem. So if you have just an absolute value and it equals a negative, you know that's no solution. No solution there. Do you feel okay with this absolute value stuff so far? Raise your hand if you do. Feel all right with it? Good. Let's see how to make a little bit more complicated equations, because right now this is pretty basic stuff. We're going to go ahead and move on into what happens when you have like true equations in there, true expressions. And we'll stop here at the end of this example. Let's write that down. So the absolute value of 4x plus 2 equals 6. Now we already learned from over here that probably this thing has 2 solutions to it. With me? Probably 2 solutions. But how in the world do we figure them out? Well, here's the deal. If we looked back over here, we knew the absolute value equaled 5. Here's what we said. If the inside of this equals 5 itself, absolute value is not going to change that. You with me? However, if the inside of this, notice how I'm saying the inside of this rather than just x. If the inside of this equaled the negative of this number, it wouldn't matter because the absolute value will make it positive, therefore it would equal that number. Are you with me? I'll say it one more time so you really get it. If the inside equals this number, you're good. Absolute value wouldn't change it. If the inside of this equals the negative of this number, you're also good, because this would change that negative into the positive. You with me? So let's take that and run with it over here. If the inside of this equals 6, you know this is going to be a true statement. You with me? Because the absolute value of 6 is going to give you 6. However, if the inside of this equals -6, is it still going to give you a true statement?
Yep.
No.
What's the absolute value of -6?
6.
So let's ask you one more time. If this equals 6, you know you're going to be okay, because the absolute value of 6 is 6. If this equals -6, what's the absolute value of -6? You're still going to be okay. Here's what this says to you. You will get 2 solutions. You're going to get, in fact, 2 equations. You can't just solve this thing directly. If I see on your test you go, oh, I just subtract 2 and divide by 4. I know you really don't understand what absolute value means. What absolute value means is that I can take the inside of this and set it equal to that number. Because if I know that if this part equals 6, the inside of it equals 6, then the absolute value of 6 is 6. However, I also know that if the inside of my absolute value equals -6, here's what I'm saying. Here's what I'm saying. What's the absolute value of -6?
6.
What's the absolute value of 6?
6.
If I set this equal to -6 and this equal to 6, my inside, it doesn't really matter because the absolute value is going to make both of those things equal to +6. Nod your head if you're with me on this so far. Let's solve this and see that that's actually true. So we'll subtract 2. 4x equals 4. We'll divide by 4. I'm going quickly through the solving of this because, well, the equations, that's the basic part. Really remembering it is the 2 equations here. That's what's important. Subtract 2, we're going to get 4x equals -8. We'll divide by 4. X is -2. Let's just go ahead and check this to make sure, okay? Are you with me? Watch. Let's plug in 1. Everybody, what's 4 times 1?
4.
Plus 2?
6.
What's the absolute value of 6?
6.
So is that a solution?
Yeah.
Let's try -2. What's 4 times -2? Plus 2.
6.
-6. What's the absolute value of -6?
6.
That's what we said is. If the inside equals -6, the absolute value will make it positive no matter what. So we get 2 solutions out of that thing. I'll write the steps on the board next time. We'll start with one of these and we'll move on. So if you remember from yesterday, what we're dealing with are these absolute value equations. And we said this about absolute value. Whatever's on the inside, absolute value will make it positive. So if it is positive, it remains positive. If it's negative, it will become positive. So according to our equations, it meant this. It said if the inside of this equation is equal to the number itself, the absolute value is not going to change it. It's going to remain that same exact positive number. That would be great. That right there yields the first equation for us. It says if this inside part equals this number, oops. If the inside part equals this number, that's going to give us one solution, because if this equals positive 6, absolute value will keep positive 6, positive 6. That will be a solution. However, what we also know about absolute value is that it will make any negative number positive. So the other option we have here is if this inside part happens to be negative 6, that absolute value will take that negative 6, it will make it positive 6, and that will be another solution to this problem. That's what we learned yesterday, and we felt okay with that last time. Good, so that gives us our two equations. We set one of them equal to the number itself. We set one of them equal to the negative of that number. Because if the inside part is equal to negative 6, the absolute value of negative 6 gives us 6. The absolute value of 6 gives us 6. That's two solutions for us. So I want you to write down this note. This is what we didn't do last time. We are going to make two equations every time we see absolute value in this class. Make two equations. The first one equal to the number. So one of them equal to the number. In this case, that's our 6. And one of them equal to the negative of that number, because absolute value will take the negative, force it to become positive, and therefore change that into another solution. So one equal to the number itself, one equal to the negative of that number. Listen, in this section, it's not actually the solving that's hard. I mean, honestly, that's like pre-algebra stuff. That's very, very easy. That one's very, very easy. The solving's not hard. It's remembering that, oh, with absolute value equations, I've got to make this equal to 2. I have to have two equations out of this. One equal to the number, one equal to the negative. The solving's easy. I mean, everybody can do that in here. That's why you're here. But if you forget to make the two equations, are you going to get this right? No, you're going to get it maybe half right. I mean, if you just solve this directly, you're going to get this one probably, because that's exactly the same thing with the absolute values, but you're going to completely miss the idea of absolute value, which is you also have to have this. You also have to know that an absolute value takes a negative and makes it positive. Therefore, that's giving us another option for a solution. Are you with me on that? So you have to know that we're going to get those two equations out of this. The solving them again, I mean, I think we did this last time, but it's not hard. I mean, the solving's the pretty nice part about this. We just go down and do what we normally do with our equations. We get our two solutions. We checked that last time to make sure they both worked. And if you want to do it again, we can do it again. 4 times 1 is 4 plus 2, that gives us 6. Absolute value of 6 is, that's where you come in, is 6. Good, yeah. So that works. If we do negative 2, 4 times negative 2, that's negative 8, plus 2 is negative 6, what's the absolute value of negative 6? 6. So they both are solutions for us. But we have to show that with our two equations. Why don't you try one of these on your own to make sure that you can handle it, and then we'll continue. There you go. Go ahead and solve that one. If you get done with this one really quickly, why don't you try another one for me? We're going to work on this one together in a second. And I'll be walking around. If you need a hand on this, let me know. Hey, this is absolute value. How many equations do you get with this absolute value problem? How many equations are you always going to get with an absolute value problem? Okay, we're going to get started on the first one here. So the first one, the way we look at this, we say, okay, absolute value equals a whole number over here. We know that if the inside of our absolute value, 2x minus 3 equals positive 5, the absolute value of positive 5 is going to give us positive 5. That's great. This is one solution, or one equation that's going to give us one solution. The other portion of this is we also know that if the 2x minus 3 equals negative 5, the absolute value of negative 5 is going to give us positive 5. That's where we're getting these two equations out of. If we solve each of these, it's going to give us our two unique solutions. We'll plug that in to double check that it does work. This should work for us. Notice how the steps are the same. You're just adding or subtracting or dividing with a different number on the side. So we'll have 2x equals 8 divided by 2. Hopefully you got 4 as one of your solutions. Did you get 4? The other one will add 3 just like we did before. That's negative 2. We'll divide by 2 and get negative 1. Check both of them. Make sure you have this right. I mean, these are pretty easy to check, right? May as well go through and do that. If we check 4, we have 2 times 4 is 8. Minus 3, that's positive 5. Absolute value of positive 5 is 5. That works. Negative 1. 2 times negative 1 is negative 2. Minus 3 is negative 5. Absolute value of negative 5 is 5. They both work out for you. How many we got both those? Good deal. Good deal. Now the next one, again, I just want you to get familiar with those fractions again. Make sure that when we see those, we don't just get stuck on them. The same process is going to work for us. We know that if the inside is equal to 1, absolute value of 1 is going to give us 1. That's great. The other equation, we're just going to make it equal to the negative of that number because we know that an absolute value of negative 1 is still going to give us positive 1. Are you starting to see why we have these two equations for absolute value every single time? Because we know that no matter what, I mean, whether you have a positive or a negative, no matter what, the absolute value is going to give us the positive version of that number. That's where this one's coming from, is from that thought. How do we solve these?
Multiply by each term by 3.
You could. There's actually two options here. You can use what we learned in chapter 7, multiply every single term by 3, and that would work. Or you could subtract 4 first and then multiply 3. Either way that you want to do that. This one's kind of nice because you have a couple options here. How many people multiplied by 3 first? How many people subtracted 3 first?
Oh, subtract 4.
I'm sorry, subtracted 4 first. Did you subtract 3? I hope nobody subtracted 3. Okay, good. Maybe I'll do one way and one the other way so you see the difference up here, okay? So first way, if you subtracted 4 first, you get x over 3 equals negative 5. And then you could multiply both sides by 3 because we have x divided by 3. The way you undo that is multiply. We got it, one solution. The other one, if you want to multiply by 3 first, this is the idea of using the LCD to get rid of denominators like we did from like chapter 7 stuff. If you want to do that, that's fine. You just have to make sure that you're not just doing this. That's going to give you the wrong answer. If you are going to multiply by 3, you got to do it appropriately. That means this term, but also this one right here. You cannot forget about that one. So if you want to multiply everything by 3, that still will simplify to 1. You get x plus 12 in this case equals 3. Do you guys see the difference there? Okay. And then if we subtract 12, what do you get, negative 9?
Yes.
So either way you do those, we should get the same answers. And you should check it. If we plug in negative 15 divided by 3, how much is negative 15? How much? Negative 5 plus 4, that gives us negative 1. Absolute value of negative 1 is 1. That works. If we do negative 9 divided by 3 is negative 3 plus 4 is 1. Absolute value of 1 is 1. That also works. How many will feel pretty good about these basic absolute value equations? Good. All right. That's fantastic. Let's start looking at a couple different scenarios. And then we'll look at the end of our section here, what happens if you have an absolute value equal to an absolute value? How can we do that sort of thing? That'll be the last thing we look at. So, moving on. You know, before when we did this, we looked at this and said, oh, I know that if the absolute value equals a number, then the inside of that could equal either the number or the negative of that number, and we're still going to be okay because the absolute value makes it positive no matter what. Does this one look exactly like this one or this one? What's different about that one that you didn't necessarily have in these two? Do you see it?
The 9 on the side of the absolute.
Yeah, that's actually going to make a big difference for you. Right? Here's what this says. When we had absolute value equal to a number, this was just the absolute value itself would make this number positive no matter what, right? It's going to equal that thing over there, whatever that number is. In this case, it says, yeah, this absolute value, that's going to make whatever is in there positive, but then I'm adding 9 to it before I have that equal to 19. This right here can be an issue for you. What this didn't do, what this didn't explain was that if you have another number over here, we can't just change this to plus and minus. We can't just make this side equal to the positive 19 and this side equal to the negative 19 because that is going to change when I subtract 9 from both those numbers. That's going to be a big issue for us. This doesn't make this whole side positive 19 or negative 19. It just makes this little part positive no matter what we put in there. Does that make sense to you? So the key here is that if we're going to solve these absolute value equations, you have to have absolute value equals a number. That's what you have to have. It has to look like this, or it has to look like this. Once we have this number at the back end of that, that's something we have to deal with first before we set up our two equations. Are you with me, folks? So I'm going to make a little note up here. You need to isolate or get the absolute value by itself before you make two equations. Isolate the absolute value before you make two equations. Essentially, you got to get it to look like this. It has to be absolute value equals number. And I'll show you why on this problem if you want to see it. So if we're supposed to isolate this first, what do you think the first thing we're going to do is? Great, let's do that. Yeah, it's got to look like that. So if we subtract 9, then we're going to get the absolute value of 5x equals 10. That looks like what we've been dealing with the whole time. Do you guys see the difference between this one and this one? How this one looks the same as that, but this one does not. Okay. If we try to do the two equations from right here, here's what would happen. I'm going to put that back on the board in just a second. I just want you to see this. If I were to make up my two equations now, that'd be one of them. That'd be the other one, right? But that 9, since it's not associated with the absolute value at this point, subtracting 9 is going to really change this problem for us. Here we'd have the 10. This is going to work out either way. This one's going to be fine for us. But this one is the one that would really mess us up. If we subtract 9 here, we're going to get negative 20, what is that, negative 28? That's going to be different from what we're about to get. You see, the problem is, if I change this 19 to a negative and then subtract 9, that's different than subtracting 9 and then changing it to a negative. We know this method, if I do 5x equals 10, we know, or absolute value 5x equals 10, we know this method works. If we had the absolute value isolated, that's what we've been doing the whole time. This method's not going to work. If you have that negative 19 first and then subtract 9, this number is going to be off. Remember the negative 28, when I go back to this, you're going to see that there's going to be a difference up here. So of course, yes, we subtract 9 first, and we get our absolute value of 5x equals 10. Okay, what now? We should know at this point. Okay, so before I start doing any actual math on this problem, before I start doing any math with this problem, I do have to make my two equations out of that. We know that absolute value says that the inside is equal to the number, and the inside is equal to the negative of that number. Because absolute value will make that positive no matter what. That would not work in this case. You can't have it equal to 19 and negative 19 because absolute value is not covering that 9. That is why we had to subtract that 9 before we do the two equations there. Hey, can you solve these? Yeah, that's not too bad. Just divide by 5. We're going to have x equals 2. Divide by 5. We'll get x equals negative 2. Let's try these just to make sure that we have this right. If I plug in 2, what's 5 times 2?
10.
Absolute value of 10?
10.
Plus 9?
19.
We got it. Negative 2. 5 times negative 2?
10.
Absolute value negative 10?
10.
10 plus 9, 19. Notice how the absolute value is only associated with this, that plus 9. That would not have worked if we would have set up the two equations without subtracting 9 first. That would have been a big problem. I'll just try one of these on your own, just to get the hang of it, get your head around it. So what do we do first? Do we subtract 8 first, or do we make two equations first?
Subtracting.
Sure. You have to have your absolute value isolated before you make those two equations. So when we subtract 8, absolute value of 3x equals 6, that's where we can make those two equations. We know that if the absolute value of 3x equals 6, then if 3x equals 6, absolute value of 6 is 6. If 3x equals negative 6, absolute value of negative 6 is 6. We just solve each of these individually, and then we have our two solutions. So we divide by 3. X equals 2. Divide by 3 over here. X equals negative 2, and we're done. How many people got that? Good for you, that's fantastic. Let's see, what else can we do with this? Let's try this problem. Hey, what do you suppose I do first on this? Why subtract the 4?
Plus add 4.
Or why add 4? I'm just doing what you guys say. Why add the 4?
Because you want to isolate.
Yeah, hey, if it's not isolated, we cannot do anything with this. We cannot make up 2 equations right here. Listen, you cannot make two equations up right here. One of them is going to be wrong. One of them is going to be right, but one of them is going to be wrong. The one where you just drop the absolute value like this one would be right all the time. If you just do the math on it, that's essentially what we're doing, right? We're just ignoring the absolute value for this side. This one's the one that's going to be wrong. So what we really have to make sure we're doing is isolating the absolute value. It's up here on the board. Isolate the absolute value before you do any making 2 equations out of this thing. Yeah, you're right, add the 4. Three times the absolute value of y gives us... Sure?
21.
Oh, that's 17 plus 4. And now what?
Divide by 3.
Good, yeah. Yeah, you're not even going to make up 2 equations yet from here. We're going to divide by 3, get the absolute value completely by itself. So since this is 3 times absolute value y, let's take care of that. If we divide by 3, yes, those 3's are gone. I get the absolute value of y equals 7. If the absolute value of y equals 7, what do you know about y?
It's 7.
Well, yeah, it is 7. That's one of our solutions. It does have 2 solutions. What's the other solution? This is actually how we opened up the introduction to this section, right? We had this type of idea. But look, you can still make 2 equations out of this, can't you? We can do y equals 7, and the inside equals the negative of that number, and that's exactly how we started our section here, doing exactly that. There's just no more math you have to do with it. This is kind of a nice problem. All the math was before you even made your 2 equations. Why don't you try that one? See what happens. By the way, is it okay to get fractions on your problems here?
Yep.
Okay, so don't be afraid of the fractions. You might get some of those. Oh, you guys are quick. Let's do this. First thing, what are you going to do? Very good. So we're certainly not going to try to make it 2 equations, right? I mean, when you look at this thing, that's equal to a negative. Some people, if they don't know what they're really doing, they're going to go, oh, absolute value equal to negative? That's no solution. Remember talking about that? Oh, that's no solution. No, we have to get the absolute value by itself before we make that determination. So, of course, we're going to add 9. I hope you did that. We'll get 3 times the absolute value of y equals 2. What are you going to do now? Or what did you do now? Great. Get rid of that 3. We certainly don't want that thing hanging around our absolute value. What we want is absolute value equals a number. That's what we need to work with this problem. So absolute value of y equals 2/3. Is that okay?
Yep, that's a positive -2.
Good, we just do the same thing we did before. Now that you have the absolute value isolated, absolute value equals a number, we say, oh, the inside can equal the number itself, because I know an absolute value will keep positive number positive. That would be one solution. But also, I need the inside equal to the negative version of that number, because absolute value will take a negative and make it positive. So y also equals -2/3. Actually, not even a whole lot of work with those fractions. You just have to make one positive, one negative. Raise your hand if you got that. Good for you, that's fantastic. I would like to change this problem a little bit. Okay, just a little bit here. What if I made that positive? What if I made that positive? How would our problem change?
I have no solution,
Explain that.
because they say it would be negative.
So if I do this right here and I say that's -2, is that okay to have? Well, we could divide by 3, but you're going to get -2/3, right? Okay. What if I did this? Is this one okay?
Yes,
Yeah. What would you have to do now?
you divide by 3 and return back
Okay,
positive.
so make sure that we're isolating our absolute value before we make determinations whether there's no solution or not. Because if we do this, if I just look at it and go, oh, absolute value is equal to a negative, there's no solution there, we're going to make a mistake because your absolute value is not isolated. You got to completely isolate that thing first. Are you seeing the point there? So if we divide by -3 here, well, those aren't going to simplify to 1. We get absolute value of y equals, what's -2 over -3? Positive or negative? Definitely, yeah, we practiced that a few times, right? And then you'd go ahead, you'd actually get the same exact solution on that problem. Same exact thing. Well, that's a way too big absolute value. There we go. Got a little crazy on my absolute value. That ever happen to you? Get a little crazy on your absolute value? I mean, all the time. You too many margaritas and absolute values are getting crazy, you know? Whatever. Just kidding. What would the first thing we'd do on this problem be?
No solution.
Well, that was easy. Why aren't we multiplying by 4? Why aren't we setting up 2 equations? Why aren't we doing any of that stuff? I want you to take a look at it. Look at it. Is that doable?
No.
Can an absolute value ever equal a negative?
No.
So this is different. This is, I kind of led you up to this problem on these two, like doing this whole thing over here. But if ever you have an absolute value and it's already isolated, is this one already isolated? And it's equal to a negative number, can an absolute value itself ever give you a negative? Ever? No. No, not if it's isolated. Over here, hey, that was equal to a negative, but this was different. It was not isolated. Do you see the difference between this problem and that problem? Here, there's nothing we can do to get rid of that negative. Here, we could divide by that -3. Negative is gone. We could work with that problem. Here, we can't. So if you ever get an absolute value, it's already isolated and it's equal to a negative number, what are you going to have? Yeah. And you put the empty set. It's that circle with the line through it. So we'd say this, there are no numbers which satisfy that equation. Would you raise your hand feel okay with these basic absolute value equations so far? Left-hand side, you guys all right? All right. Now, the last question we have to ask is, what would happen if, instead of having like an absolute value equal to a number, like we've had in every other case, what happens if we have an absolute value equal to an absolute value? So for instance, like that? What are we going to do there?
Would they have to be equal to each other?
Well, we'll talk about that. We've got several cases, okay? We've got certain cases which we're going to take a look at. What does absolute value do? No matter what, it makes it positive. You with me on that? So let's imagine a couple cases here. Let's imagine, can we pretend for a second, I don't know what these solutions are, we're going to figure out in just a minute, but can we pretend for a second that whatever we get out of this it's going to make this 10. Can we pretend that for a second? Let's see how many cases these things will be equal to each other with. How many cases make these expressions equal to each other? If this was positive 10 and this was positive 10, would they be equal to each other? Because the absolute value of positive 10 equals the absolute value of positive 10. Does that make sense to you? So when I take the absolute value, they'd be equal. That's case 1. How about this? What if this was negative 10 and this was negative 10? Would they be equal to each other there? You sure? Sure, because the absolute value of negative 10 is 10. Absolute value of negative 10 is 10. You guys still with me so far? Okay. What's another case where these absolute values would be equal to each other? I gave you 2, where they're exactly the same number here or exactly the same number here. Positive 10, negative 10, negative 10. What's another case that you could have?
10 equals negative 10.
Say that again?
10 equals negative
10 and negative, okay. So if this was 10 and this was negative 10, would these still be equal? I need you to kind of get this if you're going to understand the idea here. Are these equal or not? What's the absolute value of 10?
10.
What's the absolute value of negative 10?
10.
So when I plug them in the absolute values, they both become positive, they're still equal. There's one more case. If this is negative 10 and this is positive 10, would that still work?
Yes.
Absolute value of negative 10 is 10. Absolute value of positive 10 is 10. Do you see the 4 cases? There's actually only 2 cases. I want you to kind of see this for a second. I know I drew 4 of them up here, but these really are kind of the same idea. This idea, these first 2 are, if you have the same exact number inside your absolute value, whether they're both positive or whether they're both negative, if you have the same exact number, your absolute values will be equal to each other. Are you with me on that? Because positive 10 equals positive 10 in absolute value, and negative 10 equals negative 10 in absolute value. They're all positive 10. So far, so good? So this is case 1. You have the same exact number. Case 2. Case 2. Case 2 is the case where the insides are opposite each other. However, when you take the absolute value, it doesn't matter, because it's going to make everything positive no matter what. Do you see that case? So even though they're opposite numbers, one's 10, one's negative 10, one's negative 10, one's 10, even though they're opposite numbers here and opposite numbers here, it doesn't matter. The absolute value will make them positive, and therefore you will have an equation in this case. So first case, same exact number. Second case, opposite numbers. So just like before, this is going to lead us to, how many equations do you think?
2.
Not 4. We don't need 4 of them because these are going to work out the same. This is the same case. Same number, same number. That's one equation here. This one is when you have opposite signs. Opposite, opposite. That's another case. So we're still going to get 2 equations out of this. And here's your equations. The first one leads to this equation. The first case here, says if I just ignore the absolute values and make these insides equal to each other, I am going to get a valid solution. Does this make sense to you? If I just set these insides equal to each other, that's what this said, they are equal. So if I set the insides equal to each other, that gives me 1. So 1 without changing anything, just equal to each other. One without changing any signs, directly equal. The other one says this. The other one says, if they're opposite or off by a sign, so this is 10, this is negative 10, or this is negative 10, this is 10. We need one more equation. We need one where the first one stays the same, but the second one is negative. Okay, so one with changing the sign of the second absolute value, or second expression. Now, I always have some students ask me, well, Mr. Leonard, if we make them both the same, one without changing signs, and we do one by changing the sign of the second expression, why don't we have to also change the sign of just the first expression, and why don't we have to have the negative and the negative? Well, I'll tell you. If we had, you guys be listening on this part, okay? If we had one without changing the sign, and then we change the sign of both of them, I need you to know that this and this are equivalent. If I make these equal, do you see that this and this are the same exact same? They say the same thing. If I divide both sides by -1, don't I get that back again? So I don't need both, I just need one. Also, same thing here. If these are equal and these are equal, do you see that these are the same thing? Yes, no? If I divide both these by -1, I get that again. They're the same idea. So we don't need 4 equations, we just need 2. Okay, we just need 2. Let's go ahead and let's make these. Here's what I'm talking about. The first case says, if this inside part equals this inside part, that's here and here, then whatever we get, absolute value, we keep it the same. That's what we're saying. The second one says, if we keep the first one the same, and we change the sign of the second one, the second expression of there, absolute value is going to take those and make them both positive no matter what anyway. So the sign doesn't really matter. Do you see the similarity between what we're doing now and what we just finished doing? We keep one the same, didn't change at all. We keep the first part the same, and we're going to make the second one negative. Here's how you show that. Please watch carefully on this part. Is this accurate to do that? Is that good enough?
Yeah.
Explain why that is not good enough right there, this part.
You didn't change the second sign.
Oh, I see. So when I say negative, what I really mean by this, well, we should be like rock solid after doing chapter 7 with all that stuff. That's what we really mean, right? We're taking negative of the entire side. You need parentheses there. Do you see what's going to happen with that negative?
Yeah.
It's going to go to both. Let's solve these and see what happens. Ladies and gentlemen, first step, what are you going to do here? What now? Add 5. No, before that.
Subtract 3x.
Good. Get rid of the smaller variable. That's how you solve equations. When you have 2 variables on the same side or on different sides, so you subtract the smaller variable first. That gives you an idea about where your variable is going to end up. So here we subtract 3x from both sides. You get x minus 5 equals 5. And lastly, what do you do?
Add 5.
Yeah. You do the constants after you get rid of your smaller variable. That way you know where your variable is going to end up. Oh, that's weird. I said 10. I didn't do that ahead of time. I just guessed. Cool. Actually, it's not going to end up being 10 inside of our absolute value. It'll be something else. It'll be 35. But, yeah, actually, that was weird. Now, let's go ahead and do the next one. Here, the 4x minus 5, that's not changing, but tell me exactly what I'm going to get on the second expression.
Get 3x minus
So it changes both of our signs. Now, what are we going to do?
1. Carry the 3x.
Good, so add that to both, we can do that. We'll get 7x minus 5 equals negative 5. 7x minus 5 equals negative 5. Everybody, what's the next thing I am supposed to do?
Add 5 to both sides.
If I add 5 to both sides, I get 7x equals to how much? 0. Is that okay? Sure, sure. What are we going to do now? Yeah, do the same thing you normally do. If we divide by 7, how much does x equal?
0.
Good. 0 divided by 7 is 0. 0 divided by anything is 0. How many solutions do I get?
2.
It's absolute value. You get 2 vertical lines, you get 2 solutions. Most of the time, this is equal to 0. Let's check them to see if what I was telling you was accurate, okay? Let's plug those in there and see. We'll deal with the 10 first. Now, here's what I can tell you. The 10 should give us exactly the same thing inside of this absolute value. The 0 should give us opposites inside the absolute value. Let's see if this works. Do you guys need this anymore? Let's plug that in. If I plug in 10, what's 4 times 10?
4.
Minus 5. What's 3 times 10?
30.
Plus 5.
35.
Is the absolute value of 35 equal to the absolute value of 35?
Yes.
That works. Let's try the 0. What's 4 times 0?
0.
Minus 5. What's 3 times 0? Plus 5. Oh, those are opposites, like we thought. Is the absolute value of negative 5 equal to the absolute value of 5?
Yes.
That's another solution. That's how we're getting our 2 solutions. If you had made the first one negative and the second one negative, you would have this case again. You'd get 10 on both sides. Or you'd get 10 for your x. You'd get 35 on both sides. If you'd made this negative and this one you kept positive, you would again get negative 5. And you'd get 0 for x. That would happen either way. Why don't you try one of these on your own? We'll do one more example. We'll call it a day. By the way, this goes a lot quicker than what I just made it seem because I was explaining everything so you really understood it. These do not take a whole long time, which is kind of nice, right? We just make our 2 equations and solve them. So I'm going to give you about a minute. Go ahead and do this. How many equations did you get?
2.
You get 2 equations. That's right. If you want to give this one a try when you're done, go ahead and work on that one. Okay, I'm going to start making my 2 equations up here. So the first equation, we really don't change anything about it. We're just going to write out (2x plus 4) equals 3x minus 1. Just our standard equation without our absolute value. But the other one, actually the more important one, we do 2x plus 4, we equal, what are we going to have on the other side of that? Negative parentheses. Perfect. Raise your hand if you have exactly that on your paper. Good. You understand the idea? We need those 2 equations out of that thing. That's great. So here we'll solve these down. I'll solve this one first. We'll have the 2x plus 4 equals negative 3x, and then plus 1. Do you see where the plus 1's coming from? Yes. Are you guys with me still?
Yes.
Okay. We'll add 3x, because that's our smaller variable. We get rid of that first. We get 5x plus 4 equals 1. We subtract 4. We get 5x equals negative 3. We divide by 5, and we get x equals negative 3 fifths. Raise your hand if you got x equals negative 3 fifths. Okay. The other one, basically the same idea. We're just solving our equation here. We get 4, get rid of the smaller variable, equals x minus 1. We add 1 to both sides. We get 5 equals x. We get our two equations. How many people got that? Feel okay with it? So the idea is basically the same. We set 1 equal to our expression in there, just like we did before. We have 1 equal to the negative of that. Tina?
Wouldn't you do the the 2x first? When it's this, oh, never mind, this is negative 3x.
Yeah, you get rid of the smaller one there. Okay, let's take a look at one more problem. Now, on this one, your first step, of course, is going to be to make how many equations? 2. The first one. Tell me the first equation, please.
X plus 2 equals 4.
Equals what now?
4.
Okay, and somebody else, what's the second equation? Tell me what I'm going to write.
X plus 2
Equals?
Negative for this one's case.
Perfect. Exactly right. We have 1 equal to the expression itself. We have 1 equal to the negative of the inside of the absolute value. We solve both of them. On this case, we'll have add x to both sides. Notice we're adding x. We get 2x plus 2 equals 4. Are you with me still so far? We subtract 2. We get 2x equals 2. We divide by 2, and we get x equals 1. If you wanted to check that, you'd get 3. You'd get 3. Absolute value 3 equals absolute value 3. We're good to go. Nudge if you're with me on this part.
Yes.
Good. Now the next part. We have x plus 2 for sure. We get negative 4. What else do we get?
plus x.
Okay, you get rid of your smaller variable. What's your smaller variable?
X.
Wait a second. Okay. You know you'd subtract x, right?
Yeah. Absolutely.
Wait a second. You get 2. Wait, that's weird. I get rid of my x's. Is this a true statement?
Yeah.
No.
No, it's not a true statement. What this says in this case is that you only have one solution. This isn't the solution. You eliminated your x's. So this one gives you nothing. You only have 1 in this case. So this is one of those instances where you do get one solution, is in this case. It happens, I'm guessing you can see it if I give another one on the board in our last like 10 seconds here. If you took a look at this one, could you see that you're only going to get one solution out of this?
Yeah.
Because in one case, you're going to get the x minus 2 equals 8 minus x. This one's going to give you a solution. However, when you do x minus 2 equals negative 8 minus x, and you get x minus 2 equals negative 8 plus x, look at how those x's are going to simplify out of this expression. This one's going to give you no solution. This one will give you just one solution, whatever you're going to get out of that. How many people understood what we talked about today? Feel okay with this? Good, that's fantastic.